What's up everyone, welcome back. Patrick here, and in this video we're going to go through a couple more scenarios. This is the exact same format as the previous question. So the first scenario, the parent function 1 over x has been vertically stretched by 3, horizontally compressed by 1 over 4, shifted 2 to the right, and then 4 units up. So, like I did in the previous video, first thing I like to do is get the transformation values. And so I'll go through each transformation individually. So vertically stretched by 3. We know that that's the a value. That's going to be 3. Horizontally compressed by 1 over 4. Now remember a horizontal compression, it deals with the k value. But remember when we had a k value, what we had to do was we had to take the reciprocal, or let's just say we flipped it, in order to get the factor, or the description, let's say, in words. So now we're going the other way. We're given the factor, and we have to get the k value. So we got to go this way, so we need to flip it as well. Okay, so if you're going from the factor to the actual k value, right, the factor is the word description of the transformation. So if you're going from the k value to the word description, or the factor, you got to flip the k value. If you're going from the factor to the k value, you have to flip that factor to get the k value. So either way, you got to flip it. So horizontally compressed by 1 over 4, flip 1 over 4, that would give us a k value of positive 4. Right? So just be conscious of that flip either way that you're going. Whether you're given an equation and then describing the transformations, or in this case, given the transformations, given the factors, and then getting the k value. Shifted 2 to the right, d value is positive 2, and then 4 up, c value is positive 4. And that's pretty much it. Notice there's no mention of reflections in the x or y axis, so the a and the k value just stay positive. Now this is applied to 1 over x, so just in general, when we apply transformations to 1 over x, mentioned this in a previous example, it's going to look like that. Or you could take that a value, put it in the numerator. Like that. That's going to be the general format for this parent function. And so taking all these, let's go with this format. So we got the 3, the a value in the numerator. The k value is 4. We got x minus d, x minus 2. And then the c value is positive 4. Yeah. Right, so this here ends up being the equation for the first scenario. Right, now moving on to the second scenario, notice that the parent function is absolute value x. It's been reflected in the x-axis, so let's go through these one by one. Reflected in the x-axis, a value is negative. Horizontally stretched by 5 over 2. Now, horizontal stretch, that deals with the k value. This is the factor, so when we got to get the k value, we got to flip the factor, so the k value is going to be 2 over 5. Horizontally stretched by 5 over 2 is a k value of 2 over 5. Vertically stretched by 5 over 2, remember vertical stretches and compressions deal with the a value, but we don't have to flip the a value, so it would actually just stay as 5 over 2 over here. And remember it's negative because of that reflection in the x-axis. And then shifted 5 to the left, the d value is negative 5. Notice there's no shift up or down. C value is just 0. And those are the transformation values for these transformations here. It's applied on absolute value x, so in general, absolute value x, when we apply transformations on it, it looks like that. So we just got to take these, apply it here. So y equals negative 5 over 2. That's the a value. The k value is 2 over 5. X minus d, x minus negative 5 is x plus 5. And then c is just 0, so we don't have to write anything there. It would be plus 0. So be careful with the d values too. Remember that when we go from here to here, the sign switches. Well, when we go from here to here, the sign switches as well. because it's x minus d. So x minus -5, that would be like in brackets, would end up being x plus 5. Right? So this here is the equation for the second scenario. That is the equation for the first scenario.